The first theorem that we're going to look at is the sum of the lengths of two sides of a triangle is greater than the length of the third side. So the first theorem says the sum means to add, the sum of the lengths of two sides of a triangle must be greater than the length of the third side. So if you add any two sides of a triangle, that sum has to be greater than the third side. So let's look at an example. Which could be the lengths of the sides of a triangle? I have 4 examples right here. So what I want to do is I want to add any two sides, and I really just have to check the two smallest sides. So I'm going to add 4 plus 6. Is 4 plus 6 greater than 10? No, so that doesn't work. Let's try the next one. 8 plus 8. Is 8 plus 8 greater than 16? No. 6 plus 8. Is 6 plus 8? 6 plus 8 is 14. Is that greater than 16? No. Is 10 plus 12? Is 22? Is that greater than 14? Yes. So you want to circle choice 4. Choice 4 could be the lengths of two sides of a triangle. These other choices will not work. If you try to do it, if you actually physically did it and measured out 4 inches and 6 inches and 10 inches and tried to make them into a triangle, it just won't work. So what we really need to do, the rule that you can remember, is all you have to do is add the two smallest sides and make sure that it's greater than the third side. So if you're checking to make sure if the sides of a triangle will work, you can add the two smallest sides together and make sure that it's greater than the third side, because the rule says the sum of the lengths of two sides of a triangle is greater than the length of the third side. Okay, second example with the same theorem. If I give you two sides of a triangle, I want to find the possible values of the third side. So say I have two sides are 2 and 5 and I'm trying to figure out what the third side could be. I could just plug in numbers to see what works, like try 2. 2 plus 2 is 4. Is that greater than 5? No. Try 3. 2 plus 3 is 5. But I don't want to necessarily by just plugging in numbers and checking each one. So what I can do is I add the two sides together and I subtract the two sides, and the third side is between those two numbers. So I want to take 2 plus 5 and I'm going to add them, and 2 plus 5 is 7, and then I'm also going to subtract them. 5 minus 2 is 3. So my answer, my third side, is greater than 3 and less than 7, and I could write it like this. My third side, x, is greater than 3. Any number that's greater than 3. 3 doesn't work, but 3.1 works, 3.2, anything greater than 3, and anything less than 7. 7 doesn't work, but any number less than 7 will work. Okay, so that's our first theorem. Next theorem that we have. The longest side is opposite the largest angle. And the opposite of that is also true. The shortest side is opposite the smallest angle. So in a triangle, the longest side is opposite the largest angle, and the shortest side is opposite the smallest angle. Okay, if you need to pause the video, you can. I have a triangle DEF right here. I know angle D is 60. I know angle E is 70. Before I can find the longest side and the shortest side, I first have to find angle F. So I remember the three angles of a triangle equal 180. So I'm going to add the two angles that I know. 70 plus 60 is 130. And 180 minus 130. Angle F comes out to be 50. So angle F is 50 degrees. So now if I want to find the longest side is opposite the largest angle. Angle E is my largest angle. The longest side is going to be opposite that. So I'm going to take angle E, the 70 degrees, and I'm going to go all the way across, and the side opposite that is DF. So the side opposite angle E is DF. And then, so see, I go take angle E, the side opposite is DF. And if I want to find the shortest side is opposite the smallest angle. My smallest angle is 50 degrees, angle F. Just shoot right across to the other side. DE would be the smallest, the shortest side. Now this picture is not drawn to scale, okay, so the shortest side doesn't look like the shortest side. You have to go by the angles. So DF is the longest side right here, even though it doesn't look like it, because it's across from the largest angle, and ED is the shortest side because it's across from the smallest angle. Okay, and our next theorem says the largest angle is opposite the largest side, so the reverse, the converse of what we just did. The largest angle is opposite the largest side, and the smallest angle is opposite the shortest side. So my largest angle is opposite the largest side. I have that in red. So my largest side right here is 7. My sides are 3, 5, and 7. And as you notice, if I take the two smallest sides and add them, 3 plus 5 is 8. That has to be greater than that third side. So that first theorem works also. But my largest angle is going to be angle B because that is opposite the largest side. This is my AC is my largest side. Shoot right across. Angle B is my largest angle. My smallest angle is opposite the shortest side. So I have my shortest side right here, 3, and across from it is my smallest angle. So angle B is the largest angle. I have it color coded so you can see. And angle C is the smallest angle. Okay, and the very last thing we have is a corollary to the triangle exterior angle theorem. Remember the exterior angle, like this right here, angle 1, is equal to the sum of the two interior angles. So angle 1 equals angle 2 plus angle 3. But the measure of an exterior angle of a triangle is greater than the measure of each of its remote interior angles. So if angle 1 is an exterior angle, then angle 1 is greater than angle 2, and angle 1 also has to be greater than angle 3, which makes sense because the exterior angle equals the two interior angles added together, so angle 1 by itself would have to be greater than angle 2, and angle 1 by itself would have to be greater than angle 3. Okay, so on your Chapter 5 summary sheet, just answer the questions for 5-6, jot down any questions that you have for us tomorrow, and fill in this sum it up.